Hello, and welcome to this episode of NextToken, a new vlog where I'll be discussing all of the new innovations in generative AI happening in the open source community and academia. My name is Christopher Nuland, and I have been an open source architect and community advocate now for over 10 years, specializing in cloud native technologies, migrations, and AI. I work for Red Hat, where I am a community advocate for open source AI projects like VLLM. I work with our Neural Magic group on improving open source AI inference for predictive and generative AI. In this episode, I'll be talking to you about speculative decoding. This concept has been around for a while, but we're now seeing some significant advancements with the technology, and I'd like to share some with you. This concept uses a smaller model called a speculator that takes requests for the larger model. The smaller model attempts at making guesses of what the larger model will choose. Instead of doing this one token at a time, it will instead guess a batch of tokens to send to the larger model. Once complete, the larger model will decide what from the smaller model it will accept. It may accept all of the tokens, a subset, or reject everything and make a decision on its own. Ideally, you want the smaller model making at least 70% of the decisions for the larger model to make up for the context switching between the models. And the added cache management between the two models also makes this complicated. There is a lot more going on here from a data science perspective, so I recommend researching the concept if you want to know more. VLLM has had speculative decoding available for a while now, but is currently not using some of the state-of-the-art approaches where there's a lot of interest right now in the community. I'll talk about some of these approaches and how VLLM is working to implement them. When just using one of the current VLLM speculative decoding approaches, we can see up to a 1.5 times improvement in latency, decreasing the time between tokens. One of the newer concepts with speculative decoding, and something that is currently being worked on to be implemented into VLLM, is something called tree attention. Instead of just sending one batch of tokens into the larger model, it will send a set of batches of tokens, giving the larger model more to choose from. When sent to the larger model, the first attention layer will look something like this, a scramble of the variations provided by the smaller model. Eagle 2 and 3 are the most known implementations for speculative decoding using this approach right now. As we can see here in this chart, we see a significant improvement, at times 5 times higher than the vanilla VLLM implementation not using speculative decoding. Speculative decoding does have one drawback. When queries per second are high, we see a significant drop-off. At times, the speculative decoding approach can even take longer. This has to do with the context switching between the models. This can be handled by simply making this feature dynamic and turning it off when VLLM sees that the queries per second has gone over a certain threshold. This feature and many more are currently being implemented into VLLM. Do keep an eye on our community pages on things like X and LinkedIn to learn more about these implementations. Thank you.